Hello, and today we're going to start this video with complex rational equations. Complex rational equations. Our last video was on complex rational expressions. This is on complex rational equations. And whenever you're dealing with complex rational equations, I would tell you the first thing you want to do is clear the fractions. Now, back in pre-algebra and algebra 1, if you had a fraction like 1 over 2 equals 1 over 3 plus 1 over x, you would multiply through by 6x over 1. 6x over 1. And then you would get 6x over 1 times 1/2 equals 6x over 1 times 1/3 plus 6x over 1 times 1 over x. And then, of course, you would cancel. 2 will go into 2 one time, 3 times, 3, 2, and x will cancel that x out. And you come out with a nice equation. 3x is equal to 2x plus 6. And now you can just solve it. X is equal to 6. So that's what we're doing here. The only difference is this is a little bit more complicated, with a few more variables. That's all there is. I'm going to go through and do some odd ones. I'm not going to do all of these because I don't want to take up the whole video to do this because I've got more videos I need to be doing. But I will go through and do some of them, probably the first, the middle, and the last. So let's go ahead and do that. So let's do number 1. Let's start off real slow. And again, the difference between these and the previous is these have equal signs. So 2a minus 3 over 6 equals 2a over 3 plus 1 over 2. And if you've been watching my videos, back in the basic math and the pre-algebra videos, I told students, I tell all my students in those classes and in those reviews, if you don't learn how to find a common denominator, you can't do algebra for 2 or 3 reasons, and this is one of them. So the common denominator of 6, 3, and 2 is 6. So I'm going to take my handy dandy blue marker and I'm going to multiply by 6 over 1 all the way through. I'm going to put a baby step in there and I get 6 over 1, 6 over 1, 6 over 1. And then I'm going to multiply 2a minus 3 over 6, 2a over 3 plus 1 over 2. And now I'm going to go through with my red marker and I'm going to cancel out. 6 will cancel with the 6. 3 will cancel with that 2 times. 2 will cancel with that 3 times. Now we go through and simplify. That 6 cancels and leaves a 1, but that doesn't matter because 1 is the multiplicative identity. Basically 2a minus 3 equals 2 times 2a is 4a. And 3 times 1 is 3. Now we solve. I'm going to bring the 2a across the river. It becomes minus 2a. I'm going to bring the 3 across the river, and it becomes a minus 3. So negative 6 is equal to 4 minus 2 is 2a, and a is equal to negative 3. Now, the one thing with complex rational expressions, and you have to check. Now, why do you have to check? Because you have denominators, and you cannot have 0 in the denominator. So, on all of your complex rational equations, the check is not just to check, it's mandatory. Because if you don't check, now this one you don't have to worry about because you got all numbers right here. Now, when you have a variable in the denominator, you have to go back and check because if you get a 0 in the denominator, the whole function blows up. So in this case, you have a is equal to -3. It's okay because you have 6, 3, and 2. You can go back and check it if you want to, but you don't have to because there's no variable in the denominator. Speaking of which, let's do number 3. Okay, we're going to have this kind of a day today. Oh, that's why. There. One of these days I'm going to get training on this board. All right, number 3. 3 over 5x plus 7 over 2x equals 1. So I'm going to multiply through by 10x. I'm going to take my blue marker and I'm going to multiply through by 10x over 1. 10x over 1, 10x over 1, 10x over 1. 3 over 5x plus 7 over 2x is equal to 1. And that's going to give me, I'll take my red marker, 5x will go into 10x 2 times, 2x will go into 10x 5 times, and that's equal to 10x. So we've got 2 times 3 is 6, plus 5 times 7 is 35, is equal to 10x. 41 is equal to 10x. Divide by 10, divide by 10. So x is equal to 41 over 10, or 4.1. Now, since we have variables in the denominator, you have to go back and check. You can check to see if you got the right answer, that's fine, but some people just go back and check to see if you get a 0 in the denominator. You're not, because in order to get a 0 with 5 times x and 2 times x, x would have to be equal to 0. X is equal to 4.1, so you really don't have to check it unless you want to check it to see if you got it correct. Okay, and you go through and plug in 4.1 and do the math and see if you get, or 41 over 10 and do the math and see if you get 1. Okay? So your answer there is 4.1 or 41 over 10, if I didn't make a mistake. All right, let's try number 5. Number 5 says m over m plus 1 plus 5 over m plus 2, or sorry, m minus 1, is equal to 1. Okay, your common denominator here is shortcut number 3, m plus 1, m minus 1. So I'm going to take my handy dandy blue marker and I'm going to multiply through by m plus 1, m minus 1 over 1. Put my baby step in, m plus 1, m minus 1 over 1, m plus 1, m minus 1 over 1, m plus 1, m minus 1, over 1. Now put my equation back in, m over m plus 1 plus 5 over m minus 1 is equal to 1. And of course, you see that the m plus 1 cancels and the m minus 1 cancels. And you're left with m times m minus 1 plus 5 times m plus 1 is equal to, this over here, this is shortcut number 3, so I can rewrite that as m squared minus 1. Now I just do my algebra. M squared minus m plus 5m plus 5 is equal to m squared minus 1. The m squareds are going to cancel, because if you bring this one over here, it's going to cancel if you take this one over here. So they cancel. And that negative m plus 5m is 4m, combined like terms. And that 5 I'm going to take across the river and divide by 4, which is negative 3/2. Now, negative 3/2, again, what would you have to have a 0 in the denominator with m plus 1? You'd have to have a negative 1. What would you have to have here to have a 0? A positive 1. We don't have positive 1 or negative 1, so we don't have to worry too much about the negative 3/2 unless you want to go through and plug it in to see if you've got the answer correct, and you can do that on your own. Okay, so your answer there is negative 3/2. Let's go to number 7. Now, there's a couple of ways you could do 7, but I'm just going to go through and multiply through by 5 minus p because that's my common denominator. So 5 over 5 minus p squared over 5 minus p is equal to negative 2. And I'm going to multiply through by 5 minus p over 1. So 5 minus p over 1, 5 minus p over 1, 5 minus p over 1. 5 over 5 minus p squared, p squared over 5 minus p, and negative 2. And the 5 minus p's cancel. And you're left with 5 minus, well, this comes out to be p squared is equal to negative 2 times 5 minus p. Now, I'm going to go ahead and clean this up. So I get 5 minus p squared is equal to negative 10 plus 2p. Now, it looks like to me I've got a quadratic, so I'm going to bring the p squared over, make it positive, and bring this over, make it negative. So I've got p0 is equal to p squared plus 2p and negative 15. And here I'm going to use my reverse FOIL. And I'm going to make this small. Hopefully I can make this small. And we're going to finish the problem because I want to see if we need to plug something back in. Okay, I could use the completing the square, but I'm not because I don't have much room. So I'm just going to go through, and we're not graphing or sketching the graph. So I'm going to go through and I'm just going to use the reverse FOIL method. 0 is equal to p, and 3 and 5 gives me a middle term of 2. So I'm going to put a 3 here and a 5 here. This means 5 is positive. This means unlike. So the answer 0 is equal to p minus 3 and 0 is equal to p plus 5. Our x-intercepts are positive 3 and negative 5. Now, this is where you have to go back and check to make sure what's 5 minus 3. 5 minus 3 is negative. That's okay. 5 minus 3 is negative. 5 minus a negative 5 is 5 plus 5, which is 10. 5 plus, now if this was a 5 plus p, then you would have a problem because then you would have a 0 in the denominator. So your answers here are 5, 3, and negative 5. All right, that was number 7. So I'm going to try number 9 next, and that'll be pretty much it, and you can do the rest of it. Oh. Yeah, I pulled this off of the internet, and it didn't have the answers with them, so you'll have to go through and check your answers, plug and chug, to check your answers to make sure you got them right. And there's nothing wrong with plugging and chugging and checking. I'll give you some. There'll be some in your worksheet that goes with this video. They'll have the answers with it. All right, so I'm going to do number 9. 2b minus 5 over b minus 2 minus 2 is equal to 3 over b plus 2. Shortcut number 3 again. So we're going to use shortcut number 3 as a common denominator. So that's going to be b minus 2 times b plus 2. I'm going to multiply through by that over 1. So baby step. So b minus 2 times b plus 2 over 1. B minus 2 times b plus 2 over 1. And b plus minus 2 times b plus 2 over 1. Now I'm going to add my 2b minus 5 over b minus 2, 2 over 1, 3 over b plus 2. And you see the b plus 2's cancel, the b minus 2's cancel, and you're left with b plus 2 times 2b minus 5 minus 2 times b squared minus 4. I'm going to go ahead and do, remember that's shortcut number, this is shortcut number 3, which gives you b squared minus 4 if you were to condense it, equals 3 times b minus 2. Remember that's a b minus 2. I messed up when I... Okay, so now you do the quadratic, distributive law, not quadratic, you do FOIL, distributive, and solve. So that's going to be 2b squared. It's going to be 5b, negative 5b plus 4b. Negative 5b plus 4b is negative b. 2 times 5 is negative 10. Minus 2b squared plus 8 is equal to 3b minus 6. Now that 2b squared is going to cancel because you're combining like terms. And then negative b minus 10 plus 8 is negative 2. 3b minus 6. I'm going to bring that b over. That's going to give me a 4b. Bring this 6 over. That's 4 equal 4b. B is equal to 1. So I'm going to take that 1 and I'm going to plug it back in. Make sure I don't get a 0. 1 minus 2 is negative 1. That's okay. 1 plus 2 is 3. So your answer is B is equal to 1. So I think we just did number 1, number 3, number 5, number 7, and number 9. So that should give you some problems that you could work. And I'll also give you a handout to follow up with this one also.